We have Crypter open. We can see that you can select a file within it, or you can create a command line process. It'll then offer options for installation within a given folder. You can specify a file name or a secondary folder and a registry name. Then it offers injection options that you can determine how it will inject itself into a given process or what technique it'll use. We can see that it has the options of reg asm, reg services, and itself. Then we can also set the information about a given assembly, such as the title, description, and so on of a assembly. And we can also click random to randomize this. It has a preset list that copies from a lot of popular binaries. We can also clone from a given binary, and we would just need to select it within this window. You can also set the icon of a binary. And then once all of these options are set, you can crypt your binary here. This tool is available on GitHub. The tool is written within .NET, so I'm going to open the pre-built binary from the GitHub and put it into dmspy. Let's look at how Crypter works. You can see some of the modules and then more information and classes that are used within the binary. We can first check out the program itself, and because this is a form using .NET, we can see that the program main is just going to be calling a new instance of the form class, and we can click into this to see the real code. So we can see the initialization is just setting all of the default options for it. It is then just setting some things within the GUI, so on and so forth. What we really want to be looking at is what happened when the build button is clicked. When it's clicked, this is what will initialize the crypter, and it will start building, as we can see here. We can click into start building to check out some more of the code, and this is just changing some things within the GUI. If we scroll through this, a lot of it is GUI management. So we're going to look at the imports used within the code to find out where the real program is lying. And then within build, we can see the code that we're actually looking for. Here we have a very basic overview of a scan time crypter and a runtime crypter. Let's concentrate first on scan time crypter. Scan time crypter is for static analysis of a binary. What static analysis is when a malware is not actually detonated, but you're just looking at it from a code perspective. So you haven't detonated it within a VM or a sandbox. Antiviruses will do this first. They'll check out a binary without running it or checking what's going on the system to see if they can determine whether it is malicious or not. And to bypass this, a scan time crypter will usually work in the following order. You'll take your malware and you'll put it into your crypter. Then your crypter will spit out a decryptor and the obfuscated malware. So what the crypter will do is it will encrypt usually or obfuscate the malware that you've put in and then bundle it with a decryptor. Looking at runtime crypters, we see the same, where you'll put your malware into a crypter, but instead of using a decryptor, it will be all bundled into a stub. And what a stub is it's just code that will bundle the decryptor and obfuscated malware into one, and then do everything within memory so that it will create a new process once the malware has been decrypted or deobfuscated so that nothing ever touches the disk. And this is very useful so that the decrypted or deobfuscated malware never touches the disk, so that an antivirus may have a harder time scanning it. This doesn't always work, and this is somewhat of an older technique, but nowadays antiviruses have many different methods of detecting malware. For a basic introduction to how these concepts work, let's stick with the idea of this runtime crypter, which is what Crypter is. It will be a piece of code that will contain both the decryptor and the obfuscated malware. And once ran, it will run the malware within memory. So let's go back to looking at what Crypter is doing. Let's look at the functions within the limecrypter.build class. Within it, we see the setup build here, and this is an empty initialization of the class. And then we see AES encrypt, compile, and prepare source. So we can already get an idea of where the previously mentioned obfuscation of the malware is going to come in. And we can guess already initially, this is just a guess and not your final answer, because I recommend that you read through the entire source. But for now, let's think that maybe AES encrypt is being used to obfuscate that sample, as we saw within this theory demonstration. Looking at the compile function, we're going to see if we can confirm that theory. So looking through it, we see that it's creating a temporary directory. It's then initializing some new strings, setting some more options here. We can see some more what look like command line options or command line flags. We can see that it's a target library. The platform is built for x86 and it's got some optimizations enabled. Then it's going to be creating a path and creating some more options that it'll use later on. It's also going to look within the resources of the binary that I'm currently looking at, which is Crypter itself, and it's going to be touching those. We can see that it's just checking if what it's done has created some errors and cleaning up a little bit. The main functionality here is when it's calling the following. The AES encrypt function, after it reads all of the bytes of the given file. It's also taking the assembly icon that would have been specified within the GUI and some other information that is specified within the GUI. And we can see that within the prepare source function here. We can right click on this and we can click on analyze to see where it's used. And we can see that it's used within the call, the button build. And this is when a user would click on build. So we can see first it calls prepare source and then it starts building. So prepare source is called before the compile function that we looked at earlier. Within prepare source, we see that it's taking some of the assembly details and setting them. And then this is all being replaced within the stub and the loader. It's setting some more information, and then there's also an AES encryption routine here. So let's look at the resources which were referred to earlier to see what is within them. And within the resources themselves, we see the loader and the stub. Let's go and check out the code of both of these. First, let's look at the loader. Within the loader, we see that the main function will just call a run of a new class called nean. And then within this class, it will call initialize. It'll sleep, and then as expected, it will decrypt the resources of stub. And once that's done, it'll run it. Besides that, that's all the loader does. So to summarize, it will first load #stub from resources, AES decrypt stub, and then create an instance of stub and run it. The loader is a very simple function with only 3 individual tasks that it accomplishes. So let's go ahead and look at stub. Looking at stub, the story is a bit different. This file already looks a lot bigger than the other. So this is probably where a lot of the processes to avoid antiviruses begins. It first checks if the install flag is enabled, and if so, it will run the installer function. This is a function that will install itself into a temporary directory on the file system and then create a registry key so that when the computer is turned on, it will run the file within the temporary directory so that if somebody's malware needs to be detonated every time the victim's computer is turned on, this is how you would do it. Then it will go on to initialize a runPE class and decrypt from resources the payload. So the payload is the malware that a threat actor will give the crypter, and this will be the malware that they want to obfuscate and encrypt. And like we assumed earlier, this payload will be AES encrypted, put into the resources of the stub, and then upon runtime will be decrypted. The method that Crypter is using to bypass antiviruses is runPE. runPE is a very common